Okay, so here we are on the Common Core math website, corestandards.org/math. But as you can see, we are here at the grade 2 introduction. And as before, I'm just going to read it all the way down. We start with some big ideas, and then a quick overview, and then we will talk again about the mathematical practices that we talk about at the beginning of every single one of these grade levels. So, in grade 2, instructional time should focus on 4 critical areas. 1. Extending understanding of base 10 notation. 2. Building fluency with addition and subtraction. 3. Using standard units of measure. And 4. Describing and analyzing shapes. So now let's break this down into what that actually means, all right? And as always, I will be taking the very professional educator-focused language and breaking it down for you so that you have a realistic expectation of what is actually, going to happen during a second grade class. Students extend their understanding of the base 10 system. This includes ideas of counting in fives, tens, and multiples of hundreds, tens, and ones, as well as number relationships involving these units, including comparing. It's a terrible sentence. These are not well written. But what that says, and I'll go ahead and finish that up. Students understand multi-digit numbers up to 1,000, written in base 10 notation, recognizing that the digits in each place represent the amounts of thousands, hundreds, tens, or ones. For example, 853 is 8 hundreds plus 5 tens plus 3 ones. As you can see, this is just an extension of what we already did. In kindergarten, we learned the names of the numbers, mostly 0 through 9, maybe 10, 11, 12. In first grade, we focused really hard on the teens and getting the pattern of the numbers up to 100. And now, we are going to be going into the hundreds and the thousands, and instead of students feeling like this is a brand new thing that they've never learned before, we can just show it as an extension of the patterns we've already been working on. We're adding another unit spot. We're adding a hundreds place and then a thousands place, but that is not changing the pattern in any meaningful way. Number 2, students use their understanding of addition to develop fluency with addition and subtraction within 100. Fluency just meaning we can do it no problem. This is going to take a lot of repetition. This is going to take a lot of practice. I try very hard to make my practice problems in my classes not feel tedious by using games, by using other ways of connecting. But when it comes right down to it, when it comes to addition and subtraction and later on multiplication, there is no substitute for just practice, practice, practice. They solve problems. This is a terrible sentence, so I'm going to take a deep breath and try really hard to get through this horrible sentence in one breath, and then I'll break it down piece by piece. They solve problems within 1,000 by applying their understanding of models for addition and subtraction, and they develop, discuss, and use efficient, accurate, and generalizable methods to compute sums and differences of whole numbers in base 10 notation. Oh my God. Using their understanding of place value and the properties of operations. Look, I am not in any way, let me highlight this monstrosity. I am not in any way defending that. I'm just not. I love Common Core. I think it is the greatest thing to happen to math education in my lifetime, and I am willing to die on that hill, but my God, that is an awful sentence. All right, let's try to break this down, okay? They solve problems within 1,000. That's the main thrust of this sentence. We're going to be doing addition and subtraction within 1,000, so 3-digit numbers, and we will probably throw in word problems and visualizations and the same things that we always do that we've been doing. So they develop, discuss, and use efficient, accurate, and generalizable methods. Man, I even can't just say that one bit without stumbling over it. All this is saying is what I've been saying this whole time. All they need to do is be able to explain their steps. And the thing about generalizable means that we can take those steps and then apply them to larger and larger sets of numbers, which is what we've been doing. We started out with addition in within 10, and then within 20, and then within 100, and soon within 1,000. So all this means is using the same methods that you used for small numbers for other numbers, for big numbers, for later on negative numbers, that sort of thing. To compute sums and differences, that's addition and subtraction, and then using their understanding of place value and the properties of operations. So the fact that 100 is actually 10 tens, and the fact that a 10 is actually 10 ones, using that information, sort of synthesizing that with what we know about addition and subtraction to be able to do these problems. All that big nasty sentence was saying is we are using a lot of different methods that we can explain to get good at adding and subtracting within 1,000. They select and accurately apply methods that are appropriate for the context and the numbers involved to mentally calculate sums and differences for numbers with only tens or only hundreds. And this is like when I went on social media, when I went on Twitter, and I asked people, if you were doing 17 plus 62, how would you actually do that in your head? And I got lots of wonderful and diverse responses to that, and that's what we're talking about here. Having students be able to do math in their head, not because they're not going to have a calculator. Obviously, we all have calculators on us. So when my teacher said you weren't going to have a calculator on you, of course, they couldn't have predicted that we were going to have smartphones. Not at the time. But now that we do have calculators on us all the time, that doesn't mean that we shouldn't be instilling these patterns in students early on, because these arithmetic patterns that you use to take apart and put together numbers can later on be used in algebra to take apart and put together expressions and equations in exactly the same way. So we're going to step away from the you aren't going to have a calculator with you anymore kind of rationalization, and instead we are going to continue to lean on the fact that we are building a foundation. I'm sure you're sick of hearing me say that by now, but that's what we're doing. We are laying a foundation, and later on we're going to be building the supports and all that other stuff. Number 3, students recognize the need for standard units of measure, centimeter and inch, at least here in the United States, although again, even if you're somewhere that uses only the metric system, you should probably have a working understanding of the imperial system as well, just because we Americans do export a lot of stuff. Not as much as we used to, but we do export a lot of stuff. So you might want to have our measurement down, even though it doesn't make any sense. I recognize that. And they use rulers and other measurement tools with the understanding that linear measure involves an iteration of units. Last time we did like the line is 1, 2, 3, 4, 5 squares long. Now instead of squares, we're going to be using inches or centimeters or whatever. They recognize that the smaller a unit, the more iterations they need to cover a given length. I am 6 feet, a little bit more than 6 feet tall, but if I was looking at centimeters, because centimeters are so much smaller than feet, it would take a whole lot more of them to make me. That's what it's talking about. Number 4, students describe and analyze shapes by examining their sides and angles. Students investigate, describe, and reason about decomposing, about decomposing and combining shapes to make other shapes. Through building, drawing, and analyzing 2- and 3-dimensional shapes, students develop a foundation for understanding area, volume, congruence, similarity, and symmetry in later grades. To be clear, we are not expecting students yet to understand exactly what any of these words mean. But we do want to be able to show students that, like that triangle has less space inside it than that triangle. That is an important thing, even if we don't have the word for area yet. Okay. Grade 2 overview. So once again, we're just going to go ahead and break it down into the most fundamentals, and then once we're in Khan Academy, we're going to take those fundamentals and break them down even further. Operations and algebraic thinking. Represent and solve problems involving addition and subtraction. At this point in 2nd grade, students need to be able to write 15 plus 11 equals 26. They need to understand what the plus and the equals signs mean and how to use them, as well as the minus sign and all of that. Add and subtract within 20. That's actually a bit of a review, right? We did adding and subtracting within 20 in first grade. It's always important to review old topics that you're about to rely on. If I'm just about to use something that's going to take that adding and subtracting within 20 and make it more complicated, probably a good idea to make sure we're still good on that fundamental. Work with equal groups of objects to gain foundations for multiplication. I don't know if we're actually going to start multiplying in second grade, but we will start adding like 3 plus 3 plus 3 plus 3. And we're going to start visualizing it in a way that will lead to multiplication later. Number and operations in base 10. Understand place value. This was the same thing that we had in first grade. It was just understand place value. We're just expanding that understanding to the hundreds and the thousands place. And probably by third or fourth grade, the students will realize that there is no end to this pattern. There is no end to how big of a number you can make using this pattern, using this base 10 system that we've got. Use place value understanding and properties of operations to add and subtract. So that's like adding the ones and carrying the one group of 10 and adding the tens and maybe carrying the 100 and blah, 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 right? That's what we're talking about. Measurement and data. Measure and estimate lengths in standard units. And that's actually a thing that I have a hard time with. Sometimes I have a hard time being able to tell what a thing is, like how tall something is in feet, if that makes sense, especially with people. I have a hard time, like, if two of my friends asked me right now which one was taller, I probably wouldn't be able to answer unless it was really obvious, because I don't really think that way, I guess. But I can tell if a box is going to fit through a doorway just by looking. But I wouldn't be able to put that into feet and inches, if that makes sense. So if that's you, you are a math person too. Anyway. Measure and estimate lengths in standard units. So yeah, that just means, sort of figuring out what is a foot, what is an inch, what is a meter, how much are all of these, just getting some fluency. Relate addition and subtraction to length. So if I have a 5-foot rope and I cut 2 feet off of it, how much rope do I have left? That sort of thing. And the answer, of course, is 5 feet. They're just in 2 pieces. Work with time and money. We're going to continue talking about clocks, and we're going to start talking about money. And I really want to focus and highlight on the fact that we're doing this in second grade, dealing with money, because for some reason, there's this weird outlandish myth that Common Core math doesn't focus on practical things like money. It's right there in second grade. I don't understand what the problem is. Represent and interpret data. We're going to do a little bit more of sort of bar graphs and a few other things. Nothing too complicated in second grade. Geometry, reason with shapes and their attributes. I'm not actually sure entirely what that means, and I'm excited to find out. Now let's take a look at this mathematical practice section again, which I am zooming way in on, because these are it, right? These are the thing. The mathematical practices drive everything we do in Common Core math. So let's look at them again with this new vision of going into second grade rather than going into first grade. Make sense of problems, persevere in solving them. Still means the same thing. We're probably still going to be sticking with unrealistic arithmetic word problems. But still, being able to make sense of a problem, read it correctly, and come up with a good strategy for solving it, that's always going to be important. Reason abstractly. Abstractly is things like shapes now. Right? We're going to be thinking about how shapes move and which shape's bigger, and all of that's very abstract, but also quantitatively. If I measure which one's bigger, I can attach a number to it, and now it's a quantitative thing, and I can use math to determine how much taller it is, etc. Construct viable arguments and critique the reasoning of others. Same deal. We talked an awful lot in the outline above about creating fluency in our addition and subtraction by being able to come up with and utilize tools and strategies that work for us and that we can communicate to one another to help each other with our understanding. So this is going to be a very, very large part of second grade math. Model with mathematics, again, modeling just means applying math to the real world, and other than counting and some basic addition and subtraction, that's all we've really got. The good news is we can apply that very easily through board games or through, I don't know, jobs around the house. I've done all of those suggestions before. When I did a quick stint substitute teaching at a preschool, I would just wander up to one of the kids, hold out a certain number of Legos, and ask them to count all of the red ones. And they thought it was a game, and it was fun for them, I guess. Was not fun for me. Never doing preschool again. Nothing against it, nothing but respect for preschool teachers. I just don't deal with little kids very well. Use appropriate tools strategically. We have a toolbox now, right? We've just spent 4 streams, 2 years of in-class time developing a sense for addition and subtraction and how to tell which one to use in what situation and all of that. So that's what we're going to be doing in this second grade as well. Attend to precision. Again, that does not mean going out to 19 decimal points. Precision just means being precise about your language. Say what you mean instead of that thing. And this is a problem that I have a lot, even in high school. People say like, yeah, it's 2 because it's this and it's that and it's this over this. I'm like, what are you talking about? Tell me the thing you're talking about. The square is twice as big, blah, blah, blah. So attend to precision. Say what you mean instead of talking through context. Look for and make use of structure is going to be super important when we expand our numbers from just 120 all the way up to 1,000. Because again, it's the same pattern over and over and over again. That's the same thing with number 8. Look for and express regularity in repeated reasoning. The reason that 106 is between 105 and 107 is because 6 is between 7 and 5, and also that's the same all the way up. 906, 907, 908, like the same patterns repeat all the way up the number line, and that's what we're trying to get across. Wow, that took a while, but like I said, second grade is a big one. It's a big leap for a lot of students because this is the first time they're really going to be sitting down and quote-unquote doing math. Most of the time in kindergarten and first grade, you don't do anything more difficult than some visual addition.